Welcome everyone. The topic that we are going to discuss today is one of the most fascinating concept in aerodynamics. All right, it is about how lift is generated in the wings. Okay, so to understand that, we have to go back to 1738. Yeah, you see the formula there: P plus half rho v squared equal to constant. It was published by Mr. Bernoulli in 1738. Okay, so that formula led to the invention of these forces, exactly how lift is generated on the wings, and that led to the successful aeroplane flown by Wright brothers. Yeah, the pictures that you see is about Wright brothers. So it took around 165 years to convert that idea, the idea about how pressure and velocity is related, Bernoulli's principle, into a successful flying aeroplane. Okay, so this is what we are going to see today. I'm going to focus on how lift is generated, okay, and based on that for Bernoulli's principle. Okay, let's get into it. Now, to understand this Bernoulli's principle, when you look at the formula, it's a simple formula, right? P plus half rho v squared equal to constant. It tells the relation between pressure and velocity, right? So to understand this, we have to focus more on this term here, pressure. Yeah, if you understand pressure very clearly, the basics of it, we can easily understand what Mr. Bernoulli tried to prove and how it led to the the invention of the forces, especially the lift. Okay, so that's what we are going to focus today. So let's get into the basics of what do you mean by pressure. Okay, we have to get the grip of that. What is pressure? All right, so to understand that, I have drawn one simple diagram here. What you see is a simple bowl filled with water. Okay, imagine there is a ball inside. Now when you take the ball out, what you see is a ball that is wet completely, right? The water will be there surrounding the ball. Now how that is possible? The water is there in every part of the ball on the outside, right? So that means the water is giving some force. It is pressing the ball on all the sides, correct? Then only it is possible, right? The water is pressing the ball on all the sides. Yeah, you have to remember this word very carefully. The force that is pressing the ball on all the sides. The water is pressing it on all the sides. Now if I want to find the value of this force, let's take one unit area in this point. In this area, how much force is acting? Now this is what we call that as pressure. Okay, pressure is a force. Remember that. How this is happening? We have gravity in the air, correct? Because of gravity, everything has a force. Now, because of gravity, what's happening? The water is pressing the object in all the sides, and the object is wet completely. Meaning, the water has pressed the object in all the sides. Okay, so you take one unit area. In that area, how much force is acting? If you measure that tells the value of pressure. So pressure is nothing but a force acting in a unit area. Okay, it is a force. Remember that. If you want to understand it more clearly, it is a pressing force. Okay, pressure, pressing force. Remember that. It presses around, it pushes around your body. Okay, now come back to humans. Okay, imagine you are standing in the ground. Okay, this is ground, you are standing on the ground, and there is air, a lot of air around you, and there is gravity, right? Now because of gravity, all the air molecules are pushed down to the ground. That means, similar to water, air is also giving you pressure. And don't think it is giving pressure only from downside. Just like this water that touches the ball in every direction, the air will give you the force in every direction. Okay, it gives you the force in every direction. Okay, and this pressure is commonly called as static pressure. Okay, so why we call it a static pressure? What is the reason? Because the air is not moving, air is stationary. Okay, the air is not moving, air is stationary. But because of gravity that is pressing on the air continuously, we are having some force on us. The gravity is pushing the air molecules to our body. Okay, so but the air is not moving. Because of stationary air, we get a force. All right, that is called static pressure, stationary pressure. Okay, the pressure due to stationary air, not moving air. Imagine you are running. If you are running, now air will attack your body like this, correct? When you are running, you are going to face the air. Now when you are facing the air, it has some velocity, correct? So that is what we call as a dynamic pressure. Okay, so this also have a formula. It is simply given as half rho v squared. Okay, it tells the relation between velocity, okay, and density. Now let's understand in the most simple way what is dynamic pressure. when you are standing simply and gravity is acting on us, the air is pushing on us and pressing on us, right? We call it as static pressure, the force due to stationary air. When you are running, now air is going to attack you. When you are running, air is going to attack you. That is also giving you a force. That we call it as dynamic pressure because it has velocity. Okay. Now you remember this very clearly. Pressure is nothing but a pressing force. It presses you on all the sides. Okay, whether it is water or whether it is air, we have forces around us because of gravity. Okay, the air is being pushed down because of gravity, and because of that pushing effect, the air is being pressed down. We are having force acting on us. In water, we can feel it, but air, it is not easy to feel it because the pressure of air is 14.7 psi. Okay, that is a very simple pressure. Now if you take the density of density of water, we can understand it more clearly why density of water is very serious. Okay, now what I'm going to do is I'm going to draw. Now imagine you are on the ground. Imagine there is some water here, some ocean. It's a deep ocean. Okay, if you jump into the ocean and you go here somewhere, imagine how much pressure will act on you because of water. This much height of water will give you a force. It will press on your body, correct? So much height of water, that much dense of water will press on you. So the pressure due to water in a deeper ocean will be very high. That's why it is not safe to swim below some height, below some depth. Actually, when you go deeper and deeper into ocean, the water will be pressing on you. So the more deeper you go, there is high chance, there is a high risk for you to die. Okay, so remember that pressure is a very serious force. Just because the pressure of the air on the ground is 14.7 psi, don't take it lightly. Pressure can act on every part of our body. Okay, it presses on every part of our body, just like this ball, where pressure is touching on every part of the ball. Okay. Now I have a question here. What if I remove the forces that is pressing on the object on the top? What happens if I remove these forces by some means? Does it mean that the pressure from below, the forces from below will push the ball up? Yes, you are correct. It can happen. Now that is what led to the invention of Aerofoil, the lift producing device in the aircraft. I'm going to reduce the force that is pressing on the object while maintaining the force below. I'm not going to do anything on the force below. Okay, pressure acts everywhere, correct? So what I'm going to do is I'm going to reduce these forces on the top of the object. That means the forces from below will push the object up. So that is what I'm going to do. Okay, so how I'm going to do that? To understand that, we have to go to Bernoulli's principle first to understand how that concept works. Okay, once you understand it, it will be so easy. So to prove Bernoulli's theorem, I have drawn one tube here. Okay, what you see is that in aerodynamics term, we call it as a Venturi tube. Okay, it has one convergent section where area is reducing and area is little bit constant, and then area is increasing. Okay, so area is reducing is called convergent, converging, and then divergent, area increasing. Now imagine air or water, take any one. Let's imagine air for our example. Imagine air is going into the tube. Okay, if air is going into the tube, when it comes to the low area, what can happen here is its velocity will increase here. Okay, now why this is happening, I will give one simple example for that. All right, just give me 1 minute. Yes, to understand this, we have to go into a basic understanding of Bernoulli. What you see here is someone holding a water pipe, right? When you press the end of the pipe, what's happening to the water? It's coming out faster, correct? When you press the end of the pipe, the water is coming out faster. The speed, the velocity of the water increases when you reduce the area, right? So this is one of the easiest way to understand Bernoulli's principle. So the same manner, what I have drawn here is the same one. I have a tube, that area is reducing and then increasing. Okay, so what happens when area is reducing? Similar to the water pipe, its velocity will increase. So what happens here? The velocity of the air will increase. Okay, up to this area where the area is reducing, velocity will increase. Okay, then here it is diverging, so velocity will reduce. So here up to here, velocity increases, and here the velocity reduces. Now, what we know about velocity? When we say velocity, it is an energy, right? It's a kinetic energy. Anything that has speed has an energy called kinetic energy. So when one energy increases, by law of conservation of energy, the other energy has to reduce. You cannot simply increase one energy, okay? To change an energy from one form to another form, that is the only possible way, okay? If velocity increasing, that means pressure in that area is reducing. What pressure? See, the air is moving faster, right? If air is moving faster, the stationary air will be less in this zone. Here the air is moving slower, so the stationary air will be more outside. To put it in simple words, when velocity increases, pressure decreases, okay? These are energies. Velocity is an energy, pressure is an energy. If velocity increases and energy is increasing, that means another energy has to reduce. That is pressure. Pressure has to reduce. Then only velocity can increase. So how we are increasing the velocity? By reducing the area. If you reduce the area of the pipe, the velocity increases. That means an energy is increasing. So another energy, pressure, that will reduce. Okay. So here we have more pressure, less velocity. But when the size reduces, velocity increases, pressure reduces. Again, when size increases, area increases, velocity reduces and pressure will increase. So this is what Bernoulli tried to prove with a simple formula. What he has written, pressure, static pressure, okay, and dynamic pressure. This is what we call as dynamic pressure, okay. Or in terms of energy, if you see, this is pressure energy, this is kinetic energy. You can say in any form, static pressure, dynamic pressure, or pressure energy, kinetic energy, or simply pressure and velocity. So what Bernoulli has proved is pressure plus velocity is equal to constant. Okay, how he has said that when velocity increases, pressure will reduce by same amount, but the total value will always be same. That's what he has written as P plus half rho v squared equal to constant. Imagine here we had a velocity of 5 and pressure of 10. When the area reduces, velocity increases. Velocity will increase to 10, pressure will increase to 5. But what is the total? 15. Here total 15. So the energy is going to be same, but one energy is going to convert to another. That is what Mr. Bernoulli has proved with a simple formula. Okay. Now where this is going to help us is in aircraft, how lift is generated is the same concept here. When area reduces, velocity increases, pressure reduces. Remember this, pressure reduces. What I told about pressure? Pressure is nothing but a force that is pressing on all sides of the object because of gravity, right? Because of gravity, we have air molecules being pressed down on us and the water is touching the object in every direction. That means there is a force acting in every direction. What if I reduce the force of pressure on the top? That's what we are going to see now. That is how we generate a lift in the wings. Now when you look at this diagram, this tells this is the cross section of the wing. When you cut the wing into half and look from the side, this is how it looks. It is called aerofoil. Okay. Some call it as airfoil, some call it as aerofoil. Okay. Aerofoil. So what's going to happen in this aerofoil is, this is a section of the wing. This is how wings look from the side. Okay. Now imagine there is some air trying to go up and then come down. Okay. And there is a air leaving out like this below. We have two sections. On the top side, the aerofoil has more curvature, more camber. On bottom side, the curvature is almost flat. Some aerofoil will come with a small curvature. At most of the cases, we have a flat line or maybe a small curvature, but the top side should have more curvature. That represents an unsymmetrical aerofoil, okay? But when you take a symmetrical aerofoil, it looks like this. We have same curvature on top and bottom, okay? We'll discuss about this later. Now what's going to happen in this aerofoil is, now remember, we have air molecules present on all the sides of the object and it is pressing us on all the side of the object, right? The air molecule is pressing us on all the side of the object, correct? We have a lot of air molecules present on the ground and air is going to press on us on all the sides. Now why I didn't draw the force of pressure on the top side is, now you see, when the air goes around the aerofoil, here the velocity of the air is going to increase. Now why is going to increase? Now imagine this is the atmosphere, okay? We have a lot of air molecules present here, correct? So when aircraft is moving, the air has to come and go up in the aerofoil. When it goes up, Now here you can see the air is going to get squeezed. When air goes up, it has to interact with other air molecules here. So it has to go up and then come down. When it goes up, it's going to get squeezed in this area. When it gets squeezed, its velocity will increase. I mean the area is reducing here, right? You can see the clear picture here. The area is, we have more air molecules approaching here. When it approaches, the air molecule, you look at my hand. We have this much amount of air molecule approaching the aerofoil. Now the aerofoil is blocking the air. It's blocking. Now the area reduces and then the area increases. So when area reduces, when area of the airflow is reducing on the top of the aerofoil, when the air is getting squeezed in the top of the aerofoil, its velocity will increase. Now what we know from Bernoulli, if velocity increases, if velocity and energy increase, the another energy has to reduce. Pressure has to reduce here. What do you mean by pressure? The force that is pressing on us. Since more air molecules are moving faster, the force that is pressing on us will reduce. Pressure reduce on top of the aerofoil. What happens below? We have very small curvature. Here also air is moving. Okay, here also we will have some pressure, but comparatively you see, here the air is moving faster compared to below. Because the curvature is more on the top, the air will move faster on the top. So pressure will reduce more on the top. Whereas here, the pressure will be there. Okay, so here we have a normal atmospheric pressure. Whereas here we have very low pressure. Now what happens when you have a low pressure here, high pressure here? This high pressure air will try to push the object up. And that is how we generate the force called lift. Okay, to sum it up, I will put in simple words. Imagine, you look at my hand. This much amount of air is approaching the aerofoil. When it approaches the aerofoil, now it has to travel on the top of the aerofoil. Now the air is getting squeezed between a small area. That means it has to pass at a very high speed. It will go out with a high speed and then area increases. Okay, so here the velocity of the air increases. If velocity increases, pressure has to reduce. If pressure reduces here, but here the pressure is normal, maintained, this much pressure will push the object, and that gives you an upward force called lift. Okay, it pushes in every direction. You see, every point it pushes, so you get a force acting in every direction. Okay, so on an average, if you look at where you have maximum thickness in the aerofoil, and there we have maximum velocity, and there we have minimum pressure, and there we have maximum lift. Okay, now this point where the maximum lift acts, or we can say an average of all the pressure acts, this point is called center of pressure. Okay, this is very important in designing the aerofoil. Remember that. So where we have maximum lift, where we have maximum thickness, that point the velocity will be very high, so pressure will be very low. So here the push will be very high. So this point is where we have maximum lift. That point is called center of pressure. Okay, clear? This is how we generate lift in the aerofoil. Okay, we will see in next video how this is helpful.